Hey everyone, Brandon Quinn here. Let's take a look at a logic puzzle I created from my book Mental Mosaics called Digital Clock Numbers. Let's say that a digital clock number is a number derived from a digital clock display in the following manner. Take the hour and put it to the left of the decimal point, and take the minutes and put it to the right. So for example, 1125 becomes 11.25. The question is, for a 24-hour clock, what is the total sum of all digital clock numbers in a normal day? So by 24-hour clock, we mean there's no AM, PM. We're using essentially military time. And for a normal day, we mean there's no daylight saving times or anything like that. Pause the video now if you want to try to work out the solution for yourself, and when you're ready, come back and we'll review the answer together. You could answer this by just literally generating all of the digital clock numbers that can happen in a day and then adding them up together. But that's tedious and unnecessary work. We can delve into the problem space a little bit more to find a much simpler, equally effective solution that's also less prone to human error. We can find the solution by using a divide and conquer strategy. We're going to isolate each position on the digital clock, and what I mean by that is we'll start with the rightmost, which corresponds to the minute, followed by the one immediately to the left, which also corresponds to the tens of minutes, and etc., etc. We'll figure out how often each digit occurs in that position, multiply the digit value itself by its number of occurrences, and then at the end we'll add everything together. Starting with the first position, the rightmost position, we can see that each digit 0 through 9 appears exactly once per every 10 minutes. There are 1,440 minutes in a day, which means each of those digits appears 144 times. Multiply each digit by 144, or alternatively, as I've done here, add up 0 through 9, multiply that sum by 144, and we get the result of 6,480. Now we'll do the same process for the second position, second from the right that is. This time only digits 0 through 5 appear because after the 59th minute, of course it goes to the next hour, at which point both digits to the right go back to 0. Each of those digits, 0 through 5, occurs 10 times per hour. There are 24 hours in a day, so each digit appears 240 times. So multiply each digit by 240, or as we have done here, add up 0 through 5, multiply that by 240, and we get 3,600. Moving on to the third position, we see that digits 0 through 9 appear for all hours less than 20. Then beyond that, only digits 0 through 3 appear for the rest of the day. Digits in this position change once per hour. So, for example, the digit 0, if it's 10 o'clock, that digit will remain 0 for 60 minutes. Then if it's 10 o'clock p.m/20 o'clock, it'll be a 0 again for another 60 minutes. And then, of course, at the beginning of the day, it'll be 0 again for a total of 180 minutes throughout the day. So digits 0 through 3 occur in 180 numbers, therefore, and the rest of them occur in only 120 numbers. Multiplying this out, we see that the sum from 0 through 3 times 180 plus the sum of 4 through 9 times 120 equals 5,760. We'll repeat the process once more for the fourth position, the position all the way to the left. In this position, digit 0 appears for all hours less than 10. Digit 1 appears for all hours from 10 to 19, and digit 2 appears for the remaining 4 hours, 20, 21, 22, and 23. Digits 0 and 1 each appear in 600 numbers, which is to say they appear in 600 minutes throughout the day. The digit 0 appears in 10 hours, so 10 times 60, same thing for the digit 1. The digit 2 appears in 240 numbers, right? 60 times 4. So multiplying that out, we see that the total sum in the fourth position is 1,080. Alright, at this point we have all these sums laid out from left to right. So the leftmost sum is from the leftmost position, the rightmost sum is from the rightmost position. So what do we do with these sums? We have to add them together, but we can't just add them as they are now. We have to consider what position in the number they belong to. In the output number, the fourth position corresponding to the leftmost hour digit belongs in the tens spot, so we would multiply that sum by 10. The third position we would leave as is, or we can think about it as multiplying by 10 to the 0th power, just for consistency. The second position is the first one on the right of the decimal spot, corresponding to the leftmost minute position. So we divide that by 10, or we multiply it by 10 to the negative first power. And finally, the first position, the one all the way to the right, we multiply by 10 to the negative second power. With that, we have enough information to calculate the final value, the solution. And running through the calculation, we get a solution of 16,984.8. In other words, If you add up all of the digital clock numbers throughout the day, that is the sum that you will arrive at. And that is the solution to this puzzle. I hope you enjoyed playing through this puzzle as much as I enjoyed creating it. If you did enjoy it, please consider getting my book Mental Mosaics, which has a collection of 200 unique puzzles, majority of which I created myself. Also, be sure to like and subscribe. If you have any questions about the puzzle, any solutions, alternative solutions you came up with, please leave a comment. I'm always happy to take a look at those. Thanks for watching, and I'll see you next time.